All right, so here's an example. It's very simple. We're going to start with something easy, then we're going to move on to some that are a little more complicated. Let's say that we have a company and they produce tables. They produce tables, they sell tables, and they're hoping to profit from making tables for people. The price they charge for each table they sell is $100. It costs them $50 in materials and labor and all other costs, in variable costs, to be able to produce one table. They have fixed costs of $10,000. What kind of fixed costs? Well, they probably have machines that they use for making tables. They probably have drills. They probably have saws. They probably rent out a warehouse or some sort of place of doing business. They probably have a manager that they pay. Managers are fixed costs, not variable costs. And that's one of the reasons why businesses oftentimes lay off their managers when they're in financial trouble, because managers are not earning revenue for the business. They are a fixed cost, okay? So anyway, so they've got fixed costs of $10,000. We want to know what the break-even quantity would be. We also want to know what the total revenue needs to be in order for the business to break even. Well, we know, I gave you a formula, we know that that break-even quantity is going to be equal to the fixed costs divided by the price minus the average variable cost. And we have all these pieces of information. Now, before we solve it, now you can go ahead and solve it right now with a calculator if you want to in about 3 seconds. But I want to tell you about, I want to talk about this formula here, okay? Basically, dividing fixed costs by something means attributing a certain number. You know, how many times can we take P minus AVC? How many of these would we need in order to fulfill all of this? And that's the idea of recovering fixed costs. This P minus AVC, that gives us the idea of covering the per unit variable cost. And as long as price is larger than AVC, then we are definitely covering our variable costs. Once we're covering our average variable costs, we can then take the leftover money and apply it to the fixed costs. And however many of those that we need to cover all of the fixed costs, that is our break-even quantity. Now, I don't even want to talk about what's going to happen if price is less than average variable cost. We're going to work on that in Unit 3, but I'm going to give you a heads up. I'm going to give you a head start. If price is smaller than AVC, this business can't do business. If they have to pay out more than $10, well, in this case, if they have to pay out more than $100 to make a table, if it costs them $120 to make a table, but then they sell the table for $100, they're losing $20 every time they make a table, and they're not putting any money towards their fixed costs at all. And therefore, you can't win in that situation. You have to stop doing business right away. But we're going to talk about that in Unit 3. All right, so let's go ahead and look at this here. We're going to put in our numbers. So our break-even quantity is going to be equal to fixed costs are 10,000. So we'll put 10,000 up here, divided by price is 100, minus average variable cost is 50. And so what we have here is 10,000 divided by 100 minus 50 is 50. So we're going to have 10,000 divided by 50. 0 cancels a 0. Now we have 1,000 divided by 5, and that's going to be 200. And therefore, our break-even quantity is going to be 200. This company is going to need to produce and sell 200 tables just to cover their fixed costs. All the while, they are covering their average fixed costs. Because in order to break even, in order to have zero profit, you have to cover all of your variable costs and all of your fixed costs, right? So all the while, they're covering their average variable costs and then taking little pieces at a time to cover their fixed costs. And after they produce 200 units, if they go on to 201, 202, 203, then they can start profiting, okay? All right, so to find the break-even total revenue, we're just going to take the price, 100, and multiply it by the break-even quantity. 100 times 200, that is $20,000. So $20,000. So that means that this company is going to need to earn $20,000 in revenue just in order to break even. Then, once their sales exceed $20,000, they know that they are profiting and no longer at a loss. But if their sales are below $20,000, then they know that they are still losing money and they're still trying to get to that place where they are no longer experiencing loss. Okay, let's do a couple more examples. All right, let's look at this situation. This is probably manufactured a bit, but you never know what kind of questions you might want to ask. In this case, we know that the price being charged is $75. We know that the average variable cost is $30 per unit. And this firm is thinking they want 500 to be their break-even point. They're okay with waiting until they produce and sell 500 units. And what they want to know is how much fixed costs can they afford in doing this, in achieving break even at 500. Now, something very similar to this can happen. Let's say that if you're a finance person in a business, and what they're trying to do is they're trying to decide the viability of a project. They want to know if they can keep fixed costs at a manageable level. And if they find out that in order to accomplish this, that fixed costs would be too high, then they say, no, let's not do this project because it would cost us too much to be able to get to where our average variable cost is 30, our price is 75, and our quantity is 500. Okay, so really what we're going to do is we're going to use the same formula where our break-even quantity is equal to fixed costs divided by price minus average variable costs. Only in this case, we're going to solve for fixed costs and we're putting numbers in for everything else. Now, I don't know if you knew this mathematically. You probably did, but in case one or two of you did not know this, did you know that any mathematical equation is solvable as long as you fill in a number for every single variable except one? And that's what we're going to do here. We're going to put something here, here, and here. We're going to put a 500 in for Q. We're going to leave fixed costs as a variable. We're going to put 75 in for price. And we're going to put in 30 for average variable cost. And now we're going to start solving. So now we know that I'm going to go ahead and make this fixed costs over 75 minus 30 is 45. So now we have 500 equals fixed costs over 45. And now to solve for fixed cost, all I have to do is multiply by 45 on both sides. On the right side, it's going to cancel the denominator so that all I have left over here is fixed costs. And on the left side here, I'm going to do 45 times 500. And that's going to give me 22,500. And so, in order to achieve this situation where we break even at 500 for a price of 75 with average variable cost of $30, we can afford to have up to 22,500. And one of the things we're going to learn later in the semester is if the cost of capital is low so that we can buy everything we need for 22,500 or less, then this is going to make a good investment. This business will then be more likely to invest in this project, and that will be good for the business. It will be good for consumers. It'll be probably good for the market, and it'll be good for the economy. And so that's a place where it'll connect between microeconomics and macroeconomics. Okay. We almost forgot to calculate break-even total revenues. Now, that's very easy because in the beginning of the problem, we were given the price and the break-even quantity. Now, remember, total revenue is just simply price times quantity. So we're going to take 75 times 500. And that gives us a total revenue, break-even total revenue of 37,500. Now, you might be thinking, wait a minute, Professor Ryan, wasn't fixed costs 22,500, right? And if fixed cost is 22,500 and revenue is 37,500, then aren't we making profit? Hang on a second. You are confusing fixed costs with total cost, okay? If we are breaking even here, if total revenue is 37,500, then total cost is also 37,500. And therefore, What's the difference between total cost and fixed cost? Well, that's variable cost. So one of the things that we could now answer here is if we were asked what is the overall variable cost for this business, well, we could answer that in two ways. The first way is, do you remember that average variable cost was given as $30? So we can either multiply average variable cost times quantity, and that would give us a variable cost of 30 times 500, that would give us 15,000. The second way would be by taking total cost and fixed cost. We know that total cost is equal to variable cost plus fixed cost. And if we subtract fixed costs from both sides, okay, so that would be total cost is 37,500 is equal to variable cost plus 22,500. Sorry, I'm running out of room. Subtract 22,500 from both sides. Cancel on the right, and variable cost is now equal to 37,500 minus 22,500 is 15,000, and these match. Okay, and so you can find the variable cost associated with this business by when the firm breaks even. Now you could then also take that information and move on to understanding the marginal cost of the business when the company breaks even, and understanding the marginal revenue of the business when it breaks even. Okay. Now, just as another aside, one of the we learned about profit maximizing quantity, and one of the biggest dangers of large businesses with a lot of fixed cost is what happens if the profit maximizing quantity, where marginal revenue is equal to marginal cost. We learned that in lesson 6. What if the profit maximizing quantity is less than the break-even quantity? What if the profit maximizing quantity is occurring where the business is still at a loss? Well, this is very complicated. It's definitely not a principles level concept, but we're going to see something like that when we get to oligopoly in Unit 3. All right, so here's another situation where we're going to do sort of a reverse solution, okay? Let's say that we know that we want to break even. We want to be able to break even if we produce 1,200 units, okay? We know that our fixed costs are going to be $17,000 and that our per unit variable cost is going to be $62 per unit. What we're trying to decide here is what price should we charge. Now, technically speaking, I want you to remember that our decision about production quantity and production price is given by the profit maximizing quantity, okay? But what we're trying to determine here is what price would we have to charge at a minimum in order to break even at a quantity of 1,200. And so again, we're going to use our formula where the break-even quantity is going to be equal to the fixed costs divided by price minus average variable cost, which in this case is going to give us, we're going to put in 1,200 for quantity. We're going to put in 17,000 for fixed costs. We're going to put in P for price, and then 62 for average variable cost. Now, this one's going to be a little more complicated mathematically. We need to cancel this denominator, and we cannot separate this subtraction because addition and subtraction, they bind terms together. Well, technically they're separate terms, but it's complicated. We have to keep this P minus 62 together until it's out of the denominator. So we're going to multiply by the denominator. We're going to multiply by P minus 62, and we're going to do it on both sides. P minus 62. Over here, that's going to cancel the denominator. Over here, we have to distribute the 1,200. We've got to distribute the 1,200 to the P and also to the 62. So we're going to wind up with 1,200 P minus 1,200 times 62. I'm going to grab a calculator here. Do 62 times 1,200. That's going to give me 74,400. 74,400. And that is going to be equal to 17,000. Now, I want to solve for P. So here I'm going to add 74,400 to both sides. 74,400 to both sides. On the left, it's going to cancel, and I'm going to bring down 1,200p is equal to 17,000 plus 74,400 is going to be 91,400. Now, to solve for p, I'm going to divide by 1,200 on both sides. Cancel. Divide by 1,200. And that gives me $76 and 0.166666, which basically means it's going to be $76 and 17 cents, because we can only go, it's pennies, it's physical money. We only go to 2 decimals. Therefore, the price that this company is going to have to charge in order to break even at 1,200 will be $76 and 17 cents. Now, their break-even total revenue, and this is where you're going to get frustrated because of rounding, right? Because here's the thing. Technically, our price is 76.1666666. If I multiply that by 1,200, times 1,200, that's going to give us 91,400. 91,400. But if I were to multiply 1,200 by the practical $76.17, I would actually get 91,404. Now, here's where I want to comfort you. Technically speaking, practically speaking, this is going to be our break-even total revenue. But look how close it is to 91,400. What I would do is in one of the questions, if you were asked a question like this, I would make sure that you would get the answer correct, whether you put in 91,400 or if you put in 91,404. I think about those kinds of things when I'm writing the questions, so don't worry too much about that. Also, sometimes with some of the formula questions, I can actually set the answer to give you forgiveness up to a certain amount. Like I could say plus or minus $5, it's still correct, okay? All right, so I think we've done enough of these algebraic examples of break-even analysis. We only have one thing to look at, and that is I want to look at break-even analysis from a graphical point of view.